So let's talk a little bit on polyphase deformation and history. The reason this is important is we're looking at things in static sense at a particular time stamp. It doesn't give you the full picture. But if you look at, okay, what could have happened to this particular structure, this particular trapping elements, you probably get a better picture of, what happened through time, and then you better understand your trap integrity. So let's imagine that at a particular time we have this simple system, normal faults, gentle rollover on the hanging wall, extensional domain. We see the vertical offsets. Obviously, the fault was active during that when that stratigraphic interval was being deposited from the thickness change, meaning there was growth. That was at stage 1. So we can argue that we have some kind of trapping system formed depending on the amplitude of that hanging wall bed, the anticline on the hanging wall. So, along the line, time T2, something may have happened, some kind of shortening, either due to space constraints or crustal movements or so. What you notice is that the amplitude of the the gentle rollover, which we saw on the first, figure on the left, the amplitude has been amplified. And both on the footwall, you also see that things have changed a little bit, right? So the question at this time is, yeah, you can argue that the trap is better defined at this time, but the question is, if you had hydrocarbon in this trap, was it preserved or is it breached? And if you notice, you also notice that the strata on the hanging wall has moved up, relative to the, this equivalent on the footwall. So what that is telling us is that there is even a chance that you could have, in this case, let's assume it's sand on both sides, sand on sand juxtaposition. So the question is it breached? Do we have a leak? If we assume that this fault is not sealing, or at least at that interval, so that's a big question. Is the fault preserved, the trap preserved, or is it breached? Now, let's assume that this, shortening continued, and at a point we have some kind of reversal in the placement of these layers. What you see by this time we have inversion, right? Structural inversion. That is, telling us that somehow what we had, if it was breached, by this time you can even argue that things are worsened, right? Because it's we've almost lost the original trapping configuration that we had. Now, at this later stage, let's assume that we now have the, some kind of stress release. And when that happens, we will see some, crustal faults forming. And if we had something preserved from the stage 3, if we had some kind of, by some miracle, if we had this hydrocarbon still preserved as stage 3, the question is, after the stress release phase in stage 4, there is a chance that whatever we had preserved, we've lost it. Okay, so that that changes the story. You see, that's why it's important to think about this in terms of history, in terms of sequence, in terms of, multiple phase. What we see today in any section, seismic section or an outcrop or so, in a timestamp, it's not just the final answer. It's a question of what happened before what. That will give us a better picture of whether our trap is working, or if at the time in the past it worked or not. So the key message on this is that key message on this slide is that polyphase deformation of rock units, it happens, and it actually has direct impact on the size and integrity of our trap, and our chance of finding the right, or the right substance, in this case hydrocarbon. Our chance of finding is directly related to whether the whole, if you put all these, multiple stages of deformation together, if everything is favorable, then we have a high chance of finding hydrocarbon. But otherwise, if things turn out to be more destructive in the long term, that means that whatever play you're looking at, even though you have the right structural configuration, you may not find hydrocarbon in that trap.